Today, we're going to talk a little bit about the topic of significant figures. Significant figures are important in maintaining the appropriate precision in measurements carried out in science. In order to work with significant figures, we first must be able to recognize which digits are significant in a number. There are really two types of digits, those that are significant and those that are not, which are covered in the rules which you see on the screen in front of you. Rule 1 covers which digits are significant. Rule 2 covers which digits are not. Rather than remembering both rules, I tend to focus my attention on the digits that are significant, in other words, those covered in Rule 1. Rule 1a says that if a digit is non-zero, it is significant, which means the number, for example, 4.5 grams has two significant figures. Rule 1b says that one or more zeros between non-zero digits are also significant. For example, 5.008 kilograms has four significant figures, the 5, the 8, and the two zeros between them. 1c says one or more zeros at the end of a decimal number. This can sometimes be a confusing rule. Let's state it more simply. If you look at a number and the number contains a decimal point, the zeros at the end or after the last non-zero digit in that number are always significant. If the number does not contain a decimal point, the zeros after the last non-zero digit are not significant. So what we are looking for, again, as stated in Rule 1c, is if the number contains a decimal point, then the zeros at the end of the number are significant. For example, 50 point liters has two significant figures, the 5 and the 0. However, if we removed the decimal point and just wrote 50 liters, we would only have one significant figure, and it would be the 5. Finally, if you're looking at a number written in scientific notation, all of the digits in the coefficient, otherwise known as the number that precedes the power of 10, are significant. The last rule bears some further discussion. For example, if you had 600 and wanted to represent 600 so that it contained two significant figures, i.e. the first zero, but not the second in 600, would be significant. The only way to write that would be to write 600 in scientific notation. If you wanted it to have two significant figures, then you would have to write 6.0 times 10 to the second. If you wanted to have three significant figures, you could use scientific notation and write 6.00 times 10 to the second, or write 600 with a decimal point at the end. Either is acceptable within the scientific community. If you are not dealing with a measured number, i.e. a number obtained by using a measuring device, then you are dealing with an exact number. Exact numbers are nice because we can think of them as having an infinite number of significant figures. Exact numbers include anything that is counted. For example, 12 eggs in a carton, or 4 red shirts in your closet. Exact numbers also include any conversion within the same measuring system. For example, 12 inches in 1 foot is an exact number because both inches and feet are members of the English measuring system. A metric example might be 100 centimeters in a meter, which is also an exact number. Conversions between two measuring systems, i.e. English to metric, are not exact, with one important exception. The conversion between centimeters and inches is considered to be an exact number. In other words, there are exactly 2.54 centimeters in 1 inch by definition. Again, exact numbers are nice because they are treated as if they have an infinite number of significant figures. When you perform calculations, you must also maintain the precision of the measurements involved in the calculation. In other words, you must worry about significant figures. How you handle the significant figures depends on two things: the type of calculation you are doing and the measurements that you have made that are involved in that calculation. Your calculator will always provide the correct numeric answer, assuming you have entered the information incorrectly. However, it will not always provide the answer with the correct number of significant figures. Let's look a little bit closer at how we deal with significant figures in various calculations. Before we can get into that in any detail, it is certainly worth reviewing how to round off numbers, because we will frequently need to round off our answers to calculations to the appropriate number of significant figures. Many of you have seen these rules before. If the first digit to be dropped when you are rounding off a number is 4 or less, then it and all remaining digits are dropped. If the first digit, however, is 5 or greater, then the last retained digit is increased by 1. In either case, it is critical that when dropping digits, you do not change the magnitude of the number. Instead, you must add zeros as needed to maintain the magnitude of that number. This is perhaps best illustrated by a few examples. Let's say we had a number 14.4038, which we wanted to round to 3 significant figures. The third significant figure in the number is the second 4. That 4 is followed by a 0, so we simply drop all remaining digits. Because that second 4 is to the right of the decimal point, those digits just disappear. However, if we wanted to round 14.4038 to 1 significant figure, the practice is a little bit different. The first significant figure is the first 1 in 14.4038. That 1 is followed by a 4, which means the remaining digits are simply dropped. However, if we drop the 2 4s, the 0 and the 38, all we have left is 1. Well, 1 and 14 clearly are not the same thing. We must maintain the magnitude of the number. In other words, we must replace the first 4 that is dropped with a 0. When rounded to 1 significant figure, 14.4038 becomes 10. One last example here. If you want to take 0.5513 and round it to 1 significant figure, the first significant figure is the first 5. It is followed by a 5. So we will round the retained digit up by 1, and we get 0.6. Now that we know how to round off numbers, we can talk about how to handle significant figures in calculations. There are 2 rules when dealing with significant figures in calculations. The first applies to calculations that involve multiplication and division. That rule states that the final answer to a multiplication and division problem should have the same number of significant figures as the measurement in the problem with the fewest significant figures. For example, if you take 16.587 times 0.78 and punch it into your calculator, you will get an answer that is 12.93786. However, we need to round this answer to the proper number of significant figures. 16.587 has 5 significant figures. 0.78 has 2 significant figures, which means according to the rule, we must have an answer that is rounded to 2 significant figures. 12.93786 rounded to 2 significant figures is 13. The correct answer with the correct number of significant figures to this question would be 13. A second example, if you take 6.00 divided by 3.00, your calculator will promptly tell you that the answer is 2. However, both 6.00 and 3.00 have 3 significant figures. Therefore, your answer must have 3 significant figures, so instead of writing 2, you must write 2.00. Our second rule for calculations is the rule that is for addition and subtraction problems. The rule states that the final answer to an addition or subtraction problem has the same number of decimal places as the measurement with the fewest decimal places. This rule can be confusing and misleading. I like to think of it in a little different way, and that is, when you look at the numbers, the measurements involved in an addition and subtraction problem, your first task is to identify the least precise measurement. That is going to be the measurement with the number of digits in the fewest decimal places. For example, in the problem below, 16.00 goes to the hundredths place, whereas 2.0 goes to the tenths place. The tenths place is less precise than the hundredths place. Therefore, our final answer must be rounded to the tenths place, the same place as the least precise measurement. If you take 16 plus 2.00 plus 2.00 and enter it in your calculator, you will be told that the answer is 18. However, you must add a 0 in the tenths place and get 18.0 to get a number with the correct number of significant figures. It is possible from time to time that you will encounter a problem where you must apply both rules. The approach is not difficult if you understand the 2 separate rules for addition and subtraction versus multiplication and division. The first thing you want to do is punch the calculation into your calculator and get the calculator answer. Then you want to apply the rules for significant figures to round the final answer appropriately. For example, if you wanted to take 1.25 minus 1.1, all divided by 3.05, punching that into the calculator, you will get an answer of approximately 0.04918. However, if you assess the significant figures, you must round that answer differently. Looking first at the subtraction, 1.25 minus 1.1 indicates that 1.1 is the least precise of those 2 numbers, and it has its final digit in the tenths place, which means the only significant figure in your answer to that subtraction belongs in the tenths place. The subtraction on the calculator is 0.15. However, the only significant figure retained is the 1. If you take a number that has 1 significant figure and divide it by a number that has 3 significant figures, which is 3.05, according to the rule for multiplication and division, your answer should have only 1 significant figure, which means 0.4918 is actually rounded to 0.05. Applying both rules in a problem can be a complicated affair. This is something that should be practiced frequently, and if you have difficulties, you should definitely consult both your textbook and your instructor. I hope this video helps to clarify some of the issues that arise when applying the rules of significant figures.